Alright, this is meant as an instructional video for everybody, maybe not instructional, maybe just like a helping hand for people that are taking CSC 130 at UNCG. I've been doing this sort of stuff. I've been writing in Java specifically for about a year, so I've got a really good grasp for the basics down. So I just want to take a look at a couple of things that people have sent me questions about or they've asked on the discussion board. So far it's only been open for a couple hours, but we've had several questions that kind of stemmed back to some of the basics we've learned in the beginning. So it's important that everybody gets what the beginnings are before we try to keep moving on forward. We're all in this together. We pass or fail as a team. This is a group effort. So I'd like to help anybody or everybody, or receive help from anybody who might call out my mistakes or whatever. I just want to take a look at a couple of intro logic with Java's logic per se. I've seen, including some of my colleagues, I've seen a bit of a logical mismatch between a couple of their arguments in their code. So just want to take a look real quick. We have a string that is an object. We have several other primitives down here below. We have a scanner that's an object. We have a primitive right here. We have another primitive down at the bottom. So we have a couple of objects and a handful of primitives. So whenever you're writing these sorts of things, like our most recent lab exercise number 6, it's important that you grasp what type of object or what type of entity goes into what. When you say you have, perchance, int a, if I want int a, to equal s, there's no way that int a is ever going to equal s. Even if I say, yeah, there's not going to be any string that you can assign straight to an integer. However, it's important that if you pull up the side menu just by typing the dot, that it will immediately come up. If you look over here on the right hand side, it gives you the type of primitive object or primitive that this goes to, this object method goes to. That's very, very key to look at. Oftentimes when I'm writing code by myself, if I need to know, what sort of syntax to use, what I need to say to get things to do what I want to do, I'll just start typing dots, looking for the methods of, what makes the most sense. If I want a number, I'm looking for something along the lines of an index or a character at, because all of those involve integers. Excuse me, not caret. Caret takes an integer. But all of these give off integers. So if I wanted to find the index of h in our string above, we could have the index of the character h. Now, of course, uppercase h is a different character from lowercase h, but that's right now besides our point. So the main thing is that, when you're writing these codes, be sure to look at over here on the sideline what exactly you're trying to get out of it. So here we have a double. Doubles can be many things. You can pass an integer into a double. Specifically, if we wanted to work off of our string here again, you could pass any one of these integers to a double, because, Java will immediately promote anything that is an integer to a double. Basically, we'll just add a decimal place and 0 at the end. So it's key that we understand how our primitives are working. Still now, don't forget those things, because those will always be crucial, how your primitives work and how your objects work. Not to get too much into detail, because we haven't discussed classes further, but each object is a class to an extent. Like the math class, it's not an object, but it's part of the language pack, but if it weren't part of the Java language pack, you would have to implement it as an object. But it is a pseudo object in that it is something you can call a method off of, because objects or classes contain methods. Every class is an object, so not necessarily every object will have a method, but the objects we've dealt with so far definitely have methods. So make sure you look at all the methods and their return type, or what they give off and what they can take. That's crucial. What they can take and what they give back is very crucial as well. So if we wanted a double of anything, we can do the index of an exclamation mark. That's a good one. Index of, and we're just going to do it. It wanted to do a string, but we're going to do that. So immediately we have an integer and a double, and we've ripped two things off of a string and sent them to an integer and a double. Here we've got a character. Characters can be anything in the alphabet, a number, a special character. The key thing is a character has a width of 1, which means that a character can't. 12 is not one character. 12, the number 12, is 2 characters. If you tried to put 12 here, you'd get an error here that an unclosed literal. Basically, it is too long. If you were to do that, it works out just fine. And so we can see here, characters are single width. They have a character width of 1. So what kind of things can we toss into a character? Well, we have our string, and we're still working off of an object here. So we've done all this from an object to primitives. So we're going to try to continue this. We go s dot, and we want anything that will go to a car. Not many things are going to a car, so it looks like the only thing we have is a character at index, and that takes an integer. Because as we've seen before in class, that this you can imagine a number line underneath here, starting at 0 and going to the length minus 1. So that would be 0, E would be 1, L would be 2, and so on. Every single point that a cursor can fit in basically is a character index number. So right now we have the index number of A, that's H. So we want to get the char at, and we need to get an index at an integer, so A. So now we've worked off of our object, and we've gotten a specific character at a specific index. So if we wanted to do this anywhere in the string, it is totally independent of the idea of a scanner. If you're doing this sort of thing, you can instantiate a loop and work from the back forward. You can work from the middle back. You can work from the middle forward if you know your width, and you always do, because you know the method we'll get to right now. You know the method of s.length. So right down here we have, we'll go ahead and do this first. We have a while loop that will set c equal to whatever character at the value n of the string is. So if we want to set this equal to or less than s.length, so this s.length, this gives us an integer value of the entire length of this string. So if this were started at 0 and ended at 11, that would be 12 characters long, because we know indexing starts at 0, length starts at 1. So we want to go to less than the length. While n is less than the length, give us the character at n, which would be right now 0, and assign that to c. Now it's not going to do anything with c, but it's going to assign it. And we can set a breakpoint after this loop and get our value of c. And our value of c depending on how this works, might have to add a -1, because if that is where's it at? I think I'm not used to NetBeans so much, but okay, 44 minus 20, that's 24 characters long. So if it starts at 0, while it is less than 24, which means it can never be 24, so the max it can be is 23. We'll end up with the exclamation mark as our final character. So if we just test this out, we have okay, we'll go ahead and do this first. So we went over getting things from a string, like integers, getting doubles from a string, getting characters out of a string. Let's set up a scanner to read a string. Scanner is an object, so we're setting up an object to read off of an object. Now that little pop-up box is very important as well. In NetBeans or Eclipse, IntelliJ, whatever your preferred IDE is, if you'll just take a look at hovering over it, it'll generally tell you whatever is supposed to come in the field that's highlighted. So right now scanner is highlighted and it has a parenthesis, and you'll see all kinds of things that can go inside that parentheses. One of the things is a string. So if you look constructor scanner.scanner, it's about the 6th line up or so from the bottom of that box. It says file comma string. Up further is an input stream comma string. So that is one way to do it, but it tells you the things that are applicable and things that are not applicable. The important thing is you can, anything pretty much that contains text that's an object. Scanners can read many objects that contain text, including files, strings, the console input from the keyboard. They can read all kinds of objects. So right now we're going to tell it to read our string. So this is how an object, an input scanner, or excuse me, a scanner named input, how a scanner can read from a string. So it's going to start right here at our index of 0, and it's going to read that way. By default it reads from left to right. When you get into cursors a little bit later on, you can kind of manipulate cursor position and things like that, but that's a bit further ahead. But as of right now, we just want to get input to scan our string. So here we've got the character at every value of n, not additively, but the string just goes through and reassigns C each time. So we'll move on. Here, this is a demonstration of sort of how you could do our project. Not project, excuse me, our recent lab. The integer count here is a stand-in for the number of words. I just wanted to make a number that would go up every time the scanner found a word. So we have our while loop, excuse me, and so we take our object input, our scanner, and we call the has next. Now this is still a fairly new thing, just discussed about last week. So you might say, what is this has next? So we see a whole bunch of things. So what is has next? What is has next interpreted as? Well, has next is interpreted as a Boolean, but more importantly, what does has next mean? It means that it returns true if there's another token, and specifically with next, our token is a string. If you wanted to see if the string above had an int, you could do has next int, and it returns true if the next token of the scanner's input can be interpreted as an integer. So you can have a string with integers in it, and you can actually pull integers out of a string. That's important when you're saving files, because when you save a file, you're saving a text file as a string. So if you were saving numbers in a string, you might want to be able to pull those numbers out. So this is very important when you're scanning a file. You want to be able to pull out numbers and work with numbers, do math, things like that. Something you couldn't do with a string. But nonetheless, all of these has methods are interpreted as Booleans because it's more or less a question. It's does the scanner have, or has, does the scanner have a next string? Does it have a next integer? Does it have a next long? Does it have a next Boolean? Does it have a next double? All of those things. Those are things that don't specifically receive value, but they are a Boolean value of whether the scanner does or not. The scanner looks ahead and says, alright, is my next token, whether right now that's a character or whether it's an entire word, is my next token a string? By default, almost everything is a string. So this will most likely always be true. Anything can be interpreted as a string. So if we type has next, and has next, this is saying, does it have another token? So it's starting right here, and it's saying, does it have another token? Well, then the next thing is an H. So yes, it does have another token. It has H through O. So it grabs H through O and counts up. And then it says, after you stop at the white space, is there something past that white space? There is. There's another word. And then more white space. So by default, this thing right here is called your delimiter. Now your delimiter basically just tells a scanner when it needs to stop, or when it needs to end a token. So this is our token, hello, and we know that this token is complete when the scanner hits another white space. So as the scanner hits another white space, it knows, alright, that token is done, let me look for another token. So it scans for the next token, hits white space, that's token number 2, number 3, number 4, and number 5. So here, every time the scanner can successfully have another token, the count goes up by 1. So if you were to count this, it would be 1, 2, 3, 4, 5. So if you were just to run this piece, I think it is Shift F6. Run project. Oh, that's right. It never prints anything. So we want to oh, come on. There we go. So now we want to debug. There you go. So if we look at count, our count is 5. It counted 5 words. If we look at C, our C value is an exclamation mark because it went all the way through until it got to the very last one. If you look at our B, double, index of that is 23.0. An integer value of that is just 23. But since it's a double, it has to add a decimal and a 0. And for our integer A, you see we have a value of 0. So all of these, hopefully this is more of an explanation of how objects work, what you're expecting objects to do. Objects, on general, are expected to receive input and give off some input or output in some form, whether it be a Boolean, an integer, a double, depending on what your use case is and what method you call can differentiate what kind of output you're going to get. So we see obviously that this gives us an output of a Boolean. We want to know, does it have another thing? That's a true or false question. Yes it does, no it doesn't. rs.length, that's the length of something. So that's obviously going to be interpreted as an integer. Our index of, that's going to be interpreted as an integer. Our char at is going to be interpreted as a character. So we see how objects can be manipulated. We can get things out of other objects with an object method. So we can have our declaration and assignment. We're assigning the character at A. We're assigning the index number of exclamation mark. We're assigning the index number of H. So we've manipulated objects to work with other objects in this case and give off a primitive value in these cases. So I think that's a pretty good start as to Java and logic. So I don't know if this was helpful or not, but if it was and you'd like some more explanations for things as to how to do things in Java, feel free to leave a like or comment and let me know what's going on. Later.